Hello everyone. Today I'm going to cover two sections, 1.1 and 1.2. In our textbook, it's about angles and triangles. So let's start with angles. We first start with something called a ray. Basically a ray is like a half of a line. You start with a point called the initial point and then keep extending or lasting to the other side forever. And what if we have another ray? Let's also start from the same initial point and go into the other direction. What we have so-called an angle. Okay? The angle is measured by something called degree. As you all know, degree is denoted by the little dot, so 1 degree is written this way. So if you have a complete circle, means what? A ray, and then the second one go all the way back to the same this way. It's called a complete circle, which is twice 180, which is 360 degrees. Okay. We have some basic angles that you have heard before. If the angle is created by two perpendicular rays, and this angle is called a right angle, which is equal to 90 degrees. Right angle. Okay, it's equal to 90 degrees. All right. If the angle is less than 90 degrees, we call it the acute angle. Okay, less than 90 degrees. Less than 90 degrees. And if the angle is greater than 90 degrees, this is obtuse angle. It's more than 90 degrees. And if the angle is 180 degrees, I'll find a place to write. How about right here? Is what? Two rays, it's the same initial point, we're pointing to opposite direction. The angle is equal to 180 degrees. This is called what? Straight angle or flat angle. Let me see. It's called straight angle. Straight angle. Alright, those are the basic things about an angle. I'm pretty confident to say that all of you guys know this before. Okay, and in our trigonometry class, we will not just talk about angle, we also talk about direction of angle. Say, imagine that we are fixing the first ray right here. And if the second ray is up here and we are moving from here to here in this direction, we're going to have a positive angle. Moving counterclockwise, positive angle. The other way around, say if my first ray is right here and the second ray is down here, oops, out of inch. The second ray is down here. This is my second, and the angle is moving this way, clockwise. Then we're gonna have a negative angle. So actually, in our trigonometry class, we may have an angle of, like, say, negative 30 degrees. This one is like a positive 40 degree, for example. Okay, that are those basic information about angles. Next, I'm going to talk about some more terminologies involving two angles. What if you have two angles that sum up equal to 90 degrees? We're going to call them the complementary angle. Okay, so we say the angle is, say, 70 degrees. Right. The second angle is 20 degrees. And we said that those two angles are complementary to each other. The reason for that is the sum of two angles equal to 90 degrees. It's called complementary. Okay? Another case is, say the first angle is still 70 degrees, but the second angle is 110 degrees. what happens when we add the two angles together? The sum of the two angles is equal to 180 degrees. In this case, we're going to say that the two angles are supplementary to each other. Alright, it's just names because later on when we study trig, we're going to talk about complementaries and supplementary of the angles. They have some relationships. Okay? Now, if we want to measure the angle more precisely, then we have other units that are even smaller than degree. We have minutes and seconds, just like in our block. So, degree, start with this, right? Degree denoted by, say, 1 degree. We write this way, little dot. And then we have something called minute. 1 minute, denoted this way. And then, if we want to be more precise, we have something called second. Just like our clock, so 1 second is denoted this way. Alright, we know that 1 degree is equal to 60 minutes. And then 1 minute is equal to 60 seconds. Another word, 1 degree will be equal to 60 times 60 will be 3,600 seconds. Okay? When you guys get to the homework of this section, they may ask you to do some algebra about the measurement of angles. You may have something like this. First of all, adding angles, subtracting angle. I got like a 37 degree, 46 minute plus 21 degree, 22 minutes. And how do we add them up? We just simply add them up second to a minute to minute and degree to degree. This is 68 minutes and this is 58 degrees. And this is correct. However, the minutes right here is more than 60. It means that you can convert the 60 minutes right here into another degree. So this is the same thing as 59 degree and 08 minutes. Okay? Because 68 minutes is the same thing as 60 minutes plus 8 minutes, which is 1 degree plus 8 minutes. And then 1 degree right here, add up with the 58, you got 59. Okay? And of course, similarly, what if you got second involving? And the idea is the same, just extra word. I'm going to keep the same example, just extend more. What if I got an angle of 37 degree, 46 minutes, and then say 35 seconds? And I'm going to add up with 21 degree, 22 minutes, and 41 seconds. You guys going to do the same way. We add second to second, minute to minute, and degree to degree. 35 plus 41 is 76 seconds. 46 plus 22 is 68 minutes. And 37 plus 21 is 58 degrees. Now we have to simplify our answer. Second, 76 is 60 plus 16 minutes second, right? So this 60 seconds will become 1 minute. So this is 58 degree, 69 minute, and 16 seconds. And similarly, this number of minutes is greater than 60. We can convert into degree. So it's going to be 59 degree, 09 minute, and 16 seconds, because 69 minutes is 60 minutes plus 09 minutes. And that 60 minutes becomes 1 degree. Okay? Now let's talk about subtraction. Say I got an angle, say 42 degree, 21 minute. Subtract, how about 17 degree and 45 minutes? Okay? The idea is pretty similar, but now we're kind of going backward. Okay, it's got 21 minutes. We try to subtract 45 minutes. Obviously, 21 is less than 45. So we're gonna borrow 1 degree from 42, convert 1 degree from 42 back to minutes. So that's gonna get a bigger number. But this becomes 41 degree, and then we take 60 plus 21, which is 81 minutes. You see how I change from here to here? I take 1 degree from 42, convert into minutes. So 1 degree, 60 minutes, plus 21, become 81. And now I took 1 degree away, 41 left. The second one I keep the same, 17 degree and 45 minutes. Now I'm okay to do subtraction. 81 minus 45 is 6 right here, 36 minutes, and 41 minus 17 is 24 degree. I have the answer. And similarly, if you have second involving, you do the same thing. You can convert 1 minute into seconds, and you can have the same way of calculating the difference. Okay? The next type of exercise you will see in the homework is to convert between the decimal degrees into degree with minute and second. Say, for example, people say 16.5 degree. 0.5 means a half, right? 16.5 degree is it's the same thing as 16 degree and 30 minutes, because 0.5 here is like a half of a degree. This is the same thing as 16 degree plus 0.5 degree, and you know what a half degree is 30 minutes. 30 minutes. Okay, so in general, how do we convert? When this example was simple decimal, it gives us a hint of how to convert. The idea is this: we're going to split up the whole numbers one side and then take the decimal multiplied by 60. You're going to have the minute. For example, if I got 27.135 degree, we're going to convert into the same angle, just into the presentation of degree, minute, and second. We're going to do it this way. This is 27 degree plus 0.135 minutes. And see what we're going to do with the minute right here. We take 0.135 minutes. We're going to time 60. And that's going to give us a second. Let me get the calculator. I can calculate it right here. 0.135 times 60. This is going to be 0. 0. 63 is 18 plus 3 is 21. 8, 3 decimal, so 8.1. Alright, so this is 27 degree and 8.1 minute. Okay, and we don't want to see the decimal on the minute. Obviously, we can convert that 0.1 minute into second. And the procedure is the same way. This is 27 degree and then a minute and then 0.1 minutes. Okay, I break that 8.1 minute into 8, it's a whole number, and 0.1. Alright, now I'm going to convert 8.1 minute to second. How do I do that? I take 0.1 and multiply by 60. That's going to give me second. And this is pretty easy to calculate. It's 6 seconds. Okay? And so the final answer is going to be 27 degree, a minute, and 6 seconds. That was the idea. The idea is to break out the whole number on one side, multiply the decimal by 60. You have the next unit, which is minute, and then if the minutes you have decimal, do the same thing, break the decimal, multiply the decimal point by 60, you're going to get up to seconds. Alright? That is how we convert from decimal degree into degree with minutes and seconds. Yeah. Next question, what about the other way around? Can we convert from degree, minute, second back into decimal? So if, it kind of going backward, guys. If I have an angle, 27 degree, what was that? 8 minutes and 6 seconds. All right. I'm going to convert everything back to decimal. Of course, 27 degrees is nice enough. I'll leave it there. Convert the minute back to degree. A minute is 8 out of 60 degrees, because we learned before, 1 degree is equal to 60 minutes. In other words, 1 minute is 1 over 60 degrees. Multiply both sides by 8, because this is a minute. And then 1 second is, similarly, 1 second is 1 over 360 degrees. So this plus 6 over 360 degrees, 3600. And of course, it's going to be the same answer as before. I think, what was the number? 27 point, is that, forgot, 135. All right. That was about angles. Let me double check for that numbers, make sure that I got it right. We have 27 plus 8 over 60 plus 6 over 3600. Okay, just got messed up a little. 6 over, yeah, we have the right answer. Okay. That was about angles. There is another terminology in our book that you may need to look at. It's called the coterminal. Okay. The idea is about this. Say if you have an angle, let me show you a positive angle, say from here to here. This one is about 30 degrees. Okay? What if you also start from this ray and you kind of go like this? What means? Start from here. You all the way back here. I mean complete circle, and then move back to the center line. Alright? So what is the difference between the two angles? The first angle is just 30 degrees. The second one is 360 plus 30 degrees. Okay? So 30 degrees, and then what? 30 plus 360 degrees. And then similarly, what if I don't stop right here and I keep going one more time? Means what? Twice of 360, I got what? 30 degrees plus 2 times of 360 degrees, which is 30 right here. This is 390 degrees, and this is 720 plus 30 is 750 degrees. Those angles are called the coterminal angles because they are different by a multiple of a complete circle, a multiple of 360 degrees. And of course, you guys can move backward. Say from here, you can move this way. Okay. In other words, we don't just add 360. We can also subtract 360, and we have the coterminal angles as well. All right. Next, I'm going to talk about relationships between angles. Say if I have two parallel lines. Parallel means the two lines never intersect each other on a two-dimensional plane. They are parallel. They keep the same distance from each other. And then what if I have a third line that intersects both lines? Okay? Intersect at 2 points. Let's call this point A and this point B. I have a bunch of angles created by the 3 lines. Let's label them. Make it easy for us to call. 1, 2, 3, 4. 1, 2, 3, 4. And you guys see that those angles have some relationship. Look at angle A1. And I claim that angle A1 is going to be the same as angle B1, right? Equal to angle B1. Okay? Angle A2 on that side. The same as angle B2 or angle B4. This time let me talk about B4. And then the third pair that I want to emphasize is angle A3 equal to angle B1. Okay. A1 and B1. So on the same side, they're both above the parallel line because this pair of angles are corresponding angle. Or corresponding. Alright? And pair of corresponding angles always equal to each other. Alright? Angle A2 and B4. A2 is outside of the two lines, above the two lines. B4 is below, so the pair of angles are outside of that parallel lines, and they are in the opposite sides of that third line. We call it what? Alternative exterior angles. Exterior. Okay? And of course, similarly, A3 and B1, they are in between the two lines, and they're alternating because they're on the opposite side of the third line. So, alternating interior angles. Okay? And they have the same measurement. Okay? Pretty intuitive, so shouldn't be too hard. Let me move on. Now let's talk about triangles. Just kind of review of terminologies. If you have a triangle that has an angle equal to 90 degrees, this is called the